start off with a review from what we did on Friday, which was with rates of change and accumulation functions. So between 0 and 60 days, the number of mosquitoes is modeled by this function of mosquitoes per day. So there are 1,200 mosquitoes at time 0. So the first thing that we need to look at here is this is a rate of change function already. This function is mosquitoes per day. That means this is sort of like the derivative of our function to begin with. At time equals 20, is the number of mosquitoes increasing or decreasing? So we start to see some of our curve sketching ideas from the past come into our questions. Since this is the rate already, right, we can think of this like a derivative. It's giving us the rate. So if we want to find out if something is increasing or decreasing, we just need to find out if the rate is positive or negative. So I plug in 20, calculator question, 3 decimal places, you get negative 5.113. This would tell us that it is decreasing. The original function would have to be decreasing at that time. Right? There's no mosquitoes right now. Isn't it nice? When is it going to start increasing? What do you think? How much time do we have before you swat your first mosquito? A month? No, I think you got more time. Like end of May. Beginning of June. The worms? Oh, you slap them? I just brushed them.
No, I cry.
You cry?
Kind of burn them.
Okay.
Yeah, that's so disgusting.
According to the model, how many mosquitoes will there be at time equals 60? Since this is a calculator question, we've got an accumulation here, right? From 0 to 60 on the integral, the definite integral, that's how much the change will be. We know at time 0 there's 1,200 mosquitoes. So at time 60, we take the initial amount, we add the accumulation of change, and we get approximately 1,482 mosquitoes. These are favorite questions of the written part of the exam because they can connect lots of units, right? We have our accumulation of change, we have integrals here. The question before had curve sketching, increasing and decreasing, and now maximum number, that is using the extreme value theorem. So what do we know about the extreme value theorem? You will have on a continuous function an extreme value either at the endpoints or at any critical points in between. So what we're going to have to find out is, are there critical points? What do the endpoints look like? So if we set the rate of change equal to 0, right, and that is our original function here, it's obviously equal to 0 at 0. And then you have to think, where is sine equal to 0? At multiples of pi. So if you put in 6 pi, or 12 pi, or 18 pi, all of those places where it'll be that our rate will equal 0. And so these are all of our critical points. And these pluses, right, this is curve sketching. This tells us our function's increasing, decreasing, or decreasing. Okay. Technically, we have an endpoint here at 60. And at the conference I went to, one of the things they talked about on the exam here, since the extreme value theorem happens at endpoints or critical points, a little explanation maybe I go, can't be at endpoints. Can't be at the endpoints because of where the function is increasing and decreasing. Because of my diagram, the absolute max has to be at x equals 6 pi or at 18 pi. Okay? And I found that for me, if I was a math student, sometimes I might lose marks on the AP exam because I make an assumption that something I've done is obvious. Okay? We have 5 points that could possibly be it. 3 critical points and 2 endpoints. But logically, does it make sense you only have to check 6 pi and 18 pi? Those would be the only place logically that it would be an absolute maximum. Because 12 pi is obvious from the arrow diagrams that it's a local minimum. But a little explanation of that is important. Some people still say, some teachers say, just find them all. But this is kind of a waste of time. So now we can check 1200 plus the accumulation of change from 0 to 6 pi, and we find that local maximum at about 1,415 mosquitoes. I might lose also. Does mosquitoes have an ES at the end or just an S? English question. You will not be deducted for spelling mistakes. ES? Toes has an ES, right?
Yeah.
And you would just have one toe?
Toe. T-E. Wait, T-O. I mean, no, sorry. No, delete that.
So I don't think we can use toes as an
Oh, it's
example
easy.
because toe already has the E on it. Right? Because now we're getting into English problems. Sometimes when words end with O, you add ES, but sometimes you don't. That is like totally messed up. Like zeros, when we're finding the zeros of a function, it just has an OS. There's no E.
What about zoos?
Zoo has 2 O's. You just keep making up ones that don't fit the pattern. Zoos, I think it just has an S. That's a fun word to say. And if we do the accumulation of change of 0 to 18 pi, we get 1,526.